this video we are looking at trigonometry. So similarly to the Pythagoras video, we are looking at right-angled triangles. Okay, so these triangles are labelled slightly differently to the Pythagoras video, so I'm just going to label them now and then walk you through it. Okay, so we have here an angle, x, and opposite this we have the line which is called opposite, so that's opposite the angle x. Adjacent then is adjacent to the angle x, and then the hypotenuse, which is the longest line, which in the Pythagoras videos was labelled as c. And I think I mentioned that that was the hypotenuse. Okay, perfect. So we'll also be looking at sine, cos and tan, which you will find on your calculator. Sine, cos and tan, and we'll be using those later in some of the examples that I go through. So firstly we'll look at the formula. Right, so we have sine x equals the opposite over the hypotenuse, cos x is the adjacent over the hypotenuse, and tan x equals opposite over adjacent. So these are the three formula that you have to remember, but there are some sort of tricks to help you remember that, including a formula triangle, which we all love. And if you do physics, you do a lot of formula triangles. Okay, so these are simplified to those. So the easiest thing to remember here is SOHCAHTOA. Now I don't know, many people have different ways of remembering this. I actually find it easier just to remember SOHCAHTOA. So we're going to turn this into formula triangles. And yeah, then you use these to answer your questions. So I'm now going to go on and just go straight into some examples. Okay, so example 1. We're going to start by writing out SOHCAHTOA because that's what we're going to work with. We then want to label up our triangle, so that's similar to what we did in Pythagoras. So we've got the opposite, the hypotenuse and the adjacent, and we want to see which of those we're using. So you can see we've got a value for the adjacent, we've got a value for the hypotenuse, and we're looking for the angle. So out of these groups here, which one do we have? We have an A and a H, so that has to be using this group there. So we're going to next draw out the formula triangle. Now the one we want to find, we're going to cover that up with our finger. So we want to find the angle, so that's going to be the cos. So we cover that up and write it down. And it equals A over H. We just sub in the numbers, 6.4, 9.6, and now because we want to find x, we're going to have to do the inverse of cos. So x is going to equal cos to the minus 1 over 6.4 over 9.6, and we get that by putting shift on our calculator. So we have our calculator, turn it on. We press the shift button and then cos, and then we just type it in. And that gives us a value of 48.2 degrees. Again, so this is example 2, we're using SOHCAHTOA, and we label up opposite, adjacent, hypotenuse. We've got an O and an A, So that's using TOA at the end here. Draw the formula triangle. Middle O at the top, T times A. We want to find the angle, so we're covering up the T. We're writing tan x equals O over A. So we'll sub our numbers in. Tan x equals 4.5 over 12. Again, we're going to have to shift tan to find x. X equals 20.6 degrees. So TOA. What we do now, label up, so we've got the opposite. This is the adjacent hypotenuse. If you're a bit confused, so the hypotenuse is always opposite the right angle. Yeah, opposite's opposite the angle, and then adjacent's the other one. So here we've got opposite, and in the question, written the question down, here it says find the length YZ. So the length YZ is H. So we've got O and H using SOL. Formula triangle, O in the middle, S times H. And we want to find H this time, so we cover up the H, and that equals O over S, which is sine x. So then we just sub in the numbers. H equals 5 over sine 32. Beep boop boop on the calculator. And H equals 9.4. And here it's good to remember the units, centimetres. Okay, so here's the question. You get given this diagram, and the question is to calculate the CD, so that's this length here, to 3 significant figures, or sig figs for short, sig fig. Yeah, so start with this question. We're actually going to have to use Pythagoras because we don't have enough information here to find CD. So we need the length here, and you can see we've got a right angled triangle. We can use Pythagoras. So if we remember from a previous video, a squared plus b squared equals c squared. Put our a, b and c on here. C is the hypotenuse. A, b, sub in the numbers. Quick rearrangement and solve. So we've got the length of b. Now we go on to trigonometry. So we write down our new formula, so TOA. And we label up. So we've got the opposite, the hypotenuse, and the adjacent. Okay, so what information do we have? We want to find h, so that's involved. We've now got this value here. So we've got b. We've got the opposite, and we've got an angle, so O and H, we're using this. Write out our formula, triangle. We want to find H, so we cover up H, and we've got H equals O over sine x. So H equals O, which is our value down here, 10.583 over sine of 40. Pause, we'll do it on the calculator. So H equals 16.5. So that's 3 sig figs, And then we're also in units of centimetres, that's centimetres, and over here is also centimetres.